So in this example, we're dealing with the chemical reaction of KClO3 producing KCl and O2. What we know is that we started off the situation with 77 grams of KClO3, and the question is, what is the mass of oxygen that's produced? First step always is to determine how many moles of our known substance we actually use up. So how many moles of KClO3? To do that, the first thing we need to find is the molar mass of KClO3. So we need to pull out the periodic table here. In KClO3, we have a single potassium, and when we look up its molar mass, it weighs 39.098 grams per mole. We have a single chlorine, which weighs 35.453 grams per mole. And we have 3 oxygens, each of those oxygens weighing 15.999 grams per mole, totaling up to 47.997. Adding those all together gives us a molar mass of 122.548 grams per mole. Now that we know the molar mass of KClO3, we can find out how many moles of it we have. Looking at the mole conversion chart, we know that to find moles, we take mass and divide that by molar mass. So 77 grams divided by 122.548. Put that into a calculator and we get 0.6283 moles of KClO3. And I'm being very specific that it's moles of KClO3 because in the next step we're going to determine how many moles of oxygen will actually be produced by this. So it is important to distinguish which substance we have the number of moles of. So now, once we know the number of moles of KClO3, we can determine how many moles of oxygen will be produced. And to do that, we take our 0.6283 moles of KClO3. We need to multiply by what's called the mole ratio, which is basically the coefficients from the chemical equation. So looking back, we're looking at KClO3 and O2. KClO3, there's 2 moles of it being used up and 3 moles of O2 being produced. So when we go to multiply by the mole ratio, we'll have our 3 moles of O2 on the top. Our outcoming substance, or what we're trying to find, is always on top. And in the chemical equation, we had 2 moles of KClO3. So in that mole ratio, what we have goes on the bottom, what we're trying to find goes on top. Becomes a simple math exercise. 0.6283 times 3 divided by 2 tells us that we will produce out of this 0.94245 moles of specifically O2. So now once we know how many moles of O2 we have, we can do our last step, which is finding the mass of O2. To do that, we need the molar mass. And O2 is relatively easy because O2 consists of 2 oxygen atoms, each one of them weighing 15.999 grams per mole, giving us a molar mass of 31.998. We have the moles of O2, we want to find the mass, so looking at that mole conversion chart to find mass, That is the number of moles multiplied by the molar mass. Number of moles of oxygen, 0.94245. Molar mass of oxygen, which we just found, 31.998. Working this out, we're always following sig fig rules. The only number that matters with sig figs is the 77 grams that we were given. That has 2 sig figs, and unfortunately, when we multiply this out, we get 30 as our final answer. But if we put the line on top of the 0, we can ignore that unfortunate circumstance, and we can say that that 0 is significant. It's just happened to round that way. We have 30 grams specifically of O2.